Hello and welcome back to Ye Lab. We've explored a lot of multimodal live application development, from using the Gemini Live API to open source libraries and even commercial solutions like 11 Labs. So building an AI agent that can see and hear what you are sharing and what you're talking about is always much easier than you might think. So before we build any agents today, let's look at a framework that's called LiveKit, which makes all these implementations extremely simple. LiveKit is an open source platform designed for building applications with real-time audio and video and data features. It uses WebRTC for low latency communication to power everything from video call to interactive live streams. You can think of LiveKit as the engine that handles the complex parts of sending live media over the internet. But more than that, when you look at how it works, you will find a lot of advantage of it. So in a typical workflow with LiveKit, a user will speak to agent via app, browser, or phone call by using client SDK. And that speech is streamed from the device to agent via LiveKit Cloud. So it works as a hub to manage the communications. And then the agent receives user's speech and runs your customer business logic. So the agent development is our focus in the entire project, because we need to handle our own business logic by using custom tools, plugins, and our preferred LLMs, TTS solution, or STT solutions to meet our own custom requirement. And after that processing complete, the agent generates and streams speech back to user via LiveKit Cloud again. Now at this time, the user can hear the speech from the agent. A key part of LiveKit is its agent framework, which is what we will use in this demo today. The framework is very innovative. So when you look at how the connection to LiveKit established, you'll find the framework allows a Python program to join a LiveKit room, which is running on the cloud or a local server, just like a human user. This agent can then process the real-time audio and video from the room, send to AI services for analyze and generations, and then responds back to the user in real time. This is perfect for creating conversational AI that can see and hear in a very robust architecture. So in this video, I'm going to show you how to create a real-time AI assistant using LiveKit in 10 minutes with its simple example, and then add vision capabilities in it. So the final agent will be able to analyze a user's camera feed or screen sharing images in real time, and you can operate all of this from a React-based web application. To give you a quick feeling, check out this demo first, which we will explain the implementations in a later section. Okay, so this is the final demo that shows a React-based application with the support of LiveKit, which is deployed locally and connecting to agent that we built in the backend. So let's try to chat with the agent by start the call.
Hello, I'm here to help you with any questions or tasks you have. Additionally, I can analyze images you share or your camera feed to provide insights or information. How can I assist you today?
Can you tell me a quick joke?
Sure, here's one. Why don't skeletons fight each other? They don't have the guts.
And give me a quick introduction of quantum theory.
Quantum theory, or quantum mechanics, is a fundamental theory in physics that describes the behavior of matter and energy at the smallest scales, typically at the level of atoms and subatomic particles. Unlike classical mechanics, which accurately describes the macroscopic world we experience daily, quantum mechanics introduces some fascinating and non-intuitive principles. 1. Wave particle duality ***. Particles such as electrons and photons exhibit both wave-like and particle-like properties. This means that particles can interfere like waves, but also collide like billiard balls. 2. Quantization ***. Energy levels in quantum systems.
Now let's try sending the camera streams.
Hello. I'm here to assist you, and I can help analyze images you share or take a look at your camera feed. If you have any images or need some visual guidance, just let me know how I can assist.
Hey, what do you see in this image?
In the image, there's a man sitting in front of a microphone. Behind him, there's a colorful artwork featuring a dinosaur. The room appears to be a simple setup, possibly for a podcast or video recording. There's a visible softbox or light reflector on one side.
What is he holding?
The man is holding a red soda can.
Okay, now let's try the screen sharing feature.
Hello, I'm your helpful AI assistant, and I can assist you by analyzing any images you share or even your camera feed. If there's anything specific you'd like me to look into, or if you have any questions, just let me know. I'm here to help.
Yeah, please briefly describe the image that you are looking at.
The image is a diagram showing a system architecture involving a LiveKit cloud. It includes components like a Python agent with STT speech-to-text, LM language learning model, and TTS text-to-speech services, as well as a vision assistant agent. Inputs from a microphone and video are streamed to the cloud, and audio outputs are sent to a speaker.
Impressive, right? So its responsible is very quick through the WebRTC, and the speech output is very natural, right? There are two advantages of LiveKit that I feel attractive. The first one is it's simplifying your development. For developers, LiveKit offers APIs and SDKs that hide some of this complexity of real-time media on its cloud. This means you can focus more on your local agent development on logics rather than build the communication infrastructure from scratch that make your headache of its efficiency, the connection setup, and the stability. The other advantage is its open and flexibility. The core concept is its open concept supports integration with various AI services from the large language models to speech-to-text services or text-to-speech services that constructs your entire real-time applications from end to end. So you can choose one of its built-in lists from this SDK that is more efficient or more cost-effective to meet your own requirement. All right, let's kick things off by building our first voice agent. This will be a very basic assistant that I copied from its official repository that you can talk to from your computer's terminal to the agent. This will help us understanding the basic setup of all the LiveKit applications. So to get started, you'll need a few things. First, you will need a LiveKit cloud account, which you can get for free, and it will give you the API keys that you need in your agent development. And then you will also need API keys from a few AI providers, including the OpenAI API keys that I will not show here today. You must be very familiar with. For the solution for speech to text, I use the service called Deepgram, and you can also apply your API keys for free for a large amount of free credits. And for the text to speech solution, I choose this solution from Cutshare. You can also apply for its API key for free with free tier credits. Alright, let's break down what's happening in this system diagram. This outlines how speech from a user is processed by the agent and how the spoken response is generated to send back. It's very simple. First, the process starts with a user's speaks into their microphone. It creates an audio stream that's sent over the internet to the LiveKit cloud. From there, the LiveKit routes the audio stream to our running Python agent. Inside the agent, the audio first goes to the STT service that converts the spoken words into the written text. And this text passed to the LLM, like OpenAI model GPT-4o, which we use in this demo, to generate a text-based response quickly. And that text response is sent to the TTS service, converts the written text back into the spoken audio, create the agent's voice, and then sends this newly generated audio stream back to the LiveKit cloud, and LiveKit cloud instantly routes this response back to the user, who here is through their speaker. Now let's jump right into the project setup and code. The first thing we need to do is to install the necessary Python packages. So run the pip install with these packages, especially the LiveKit agents and plugins in the compatible versions. Next, we need to create an environment file .env in your project folder. This file will store all your API keys. Add your DeepGram API key, OpenAI API key, Catshare API key, together with the LiveKit URL, LiveKit API key, and LiveKit API secret that you can get from providers accordingly. And what this short code actually doing is setting up an agent session which manages the flow of the data. It connects STT, LLM, TTS into a pipeline. So the audio comes in, gets converted to text by DeepGram. The text is sent to OpenAI to generate a response, and the response text is converted back to the audio by Catshare. And also the other supported VAD and turn detection need to be activated. And then you start the session by defining the room and import the assistant that we initialized before, together with a greeting message that open up the agent speech right after the session setup. That's very simple. So let's run this agent. But before we run it, you need to download some model files. Just run the command in your terminal, python agent.py, download files. And then you can run the Python agent py again, but add the console that can run this agent locally in your terminal. Hey, how are you today?
Hello. I'm just a program, so I don't have feelings, but I'm here and ready to help you with anything you need. How about you? How are you today?
I'm good. Just give me a quick joke about an animal.
Sure. Here's one for you. Why did the cow go to outer space? Because it wanted to see the moon.
So just like that, you can have a conversation with your AI assistant directly through the terminal, just with about 50 lines of code. Okay, now that we have the basic agent setup, let's move on to a real interesting part, that adding the real-time vision and a UI into the whole demo project, just like the app we showed earlier. We're going to upgrade our agent to handle video. So we want agent to see what the user sees through their camera or screen sharing and answer questions about it. The main idea is to capture frames from user's video stream and send the most recent frame to the AI model along with the user's spoken question. To do that, we need to implement another two key things. a new vision agent in Python that's running in background, connecting to LiveKit Cloud, and a front-end web page for the chat. So don't worry, it's still very simple in the whole development. In the upgraded diagram, the user is now sending two streams to LiveKit Cloud. One is the existing audio stream from their microphone. The other is a new video stream from their camera or screen sharing capturing. And then the LiveKit Cloud routes both of the streams down to our Vision Assistant agent deployed locally. Inside that agent, the audio is still goes through the STT service to convert the speech audio to be text, but at the same time, the video stream is handled by a new component called Video Frame Processor, whose job is to grab the most recent frame from the video, resize it, and get it ready for the AI with the text output from the STT service. So from the LLM service perspective, it will receive a query that have both the text and images inside of it. From there, the process is similar to our voice-only agent. The LLM generates the text response, and that text goes to the TTS service to be converted back to the audio and sent to the user through the LiveKit Cloud from their speaker. Now let's quickly go through the code. So first is the same. Don't forget to pipe install all these LiveKit agents and plugins in the proper versions. From this code, this time we introduce a new class called Vision Assistant that derived from the agent class. Here we have a special method to handle incoming video frames. First, when the agent joins a LiveKit room, the onEnter method is called. This method looks for any video streams from participants. If it finds one, it will start processing the video. When processing the video frames, the create video stream method is responsible for handling the video feed. Here it creates an RTC video stream, which gives us access to the individual frames of the video. To keep things efficient, each frame is resized and compressed into a JPEG. The image data is then encoded into a base64 string and stored in a variable called latest frame. This variable always holds the most recent frame that will be only used by LLM model. Here we also reserved an image received method listens for the data on a specific channel called images. Here it can possibly use an uploaded image directly when a user uploads one. But in this demo, we have not activated this function in the front end. Now the next part is very important. The onUserTurn completed method is called after the user has finished speaking. Just before sending the user's question to the LLM model, this method checks if there is a new video frame in the latest frame variable. If there is, it attaches that frame into the message, and this means the LLM gets both the user's text and image of what was in front of them at that exact moment. Okay, so finally in our entry point, addition to the session creation and initialization, we just have to make sure we set the video enabled as true in the room import options to tell the agent to accept the video input, and then give the instructions to the model to generate the automatically reply at beginning by greet the user and let them know you can analyze images they share or their camera feed. So let's run this vision agent. It's the same that if you didn't download the necessary agent files with the command python vision agent.py and download files. You should do that. Now to run this agent, because we need this agent to be in the backend to support a front-end web app, so the agent bring up command should be Python agent vision agent.py dev instead of the console. So you will see the process initialized. The register worker has been done by successfully connecting to my LiveKit server. And now the backend agent is running. But a complete application needs a front end, right? So instead of build one from scratch, we can use a pre-built example from LiveKit library, LiveKit examples, which is the agent starter React project. This React application provides a ready-to-use interface that connects to your LiveKit server. It handles the camera and microphone permissions and streams to your agent. To get the front end running, you can follow my steps. So first you will need a Node.js and Git installed to make sure the follow-up command can be used. So let's clone the repository by copy the LiveKit example agent start React address. Okay, the project is cloned. Let's first install the dependencies by using the pnpm command install. Okay, after all the packages installed, let's configure our environment variables. So let's copy .env example to a new file .env local. Okay, from the local file, we have to provide our LiveKit API key, LiveKit API secret, and LiveKit URL. Okay, then we can run this front-end server by pnpm dev. Okay, my 3000 port has been used, so it will automatically switch to 3001 port. And when you try to open the page, the React will compiling all the components and present the UI to your browser later. Okay, it's compiled. And now you see the front end has been successfully run and your local host 3001 successfully. So if you have your backend agent running, you can directly start the call.
Hello, I'm here to help you, and I can analyze images you share or even your camera feed. If you have any questions or need assistance with something visual, feel free to let me know.
Now it's time for you to create more features and user experience into the backend agent or front-end web application. That's all for today. I hope you found it helpful. The source code for all the examples is linked in the description below, so feel free to play around with this code and make it your own. Thanks for watching. I'll see you in the next video.